Good morning, everybody. I wanted to do a quick example with you for hypothesis testing for means. I tried to give a quick overview in a video on Monday. Hypothesis testing takes a lot of thought and patience. As I've said before, I don't perceive hypothesis testing as something that's like cognitively difficult, but my perception is it takes time and patience and a lot of thought. I don't do hypothesis testing every day. By nature, I'm not a statistician. I enjoy studying statistics, but that means that I really have to think logically and methodically through every single hypothesis test. So sometimes this can be a little disconcerting if you have been, hey, I'm really good at math, I get the answers very quickly. If speed is your metric for success, then you're going to have to readjust your thinking for hypothesis testing because this takes some thought. Okay, all of that build up, let's go. I chose this sample, this question from, let's see, what number is it? Gosh, I don't see what number it is. From our My Open Math. It's hypothesis testing for means. That means I have a little data set. There's a couple of these questions with a very large data set. Sorry about that. I wish there was something in between. I'm choosing the tiny data set for my example just because I'm not taking this class and I have that option. So just to walk through this, we have no context for this story. We don't know what it is, but we do know that whatever the context is, maybe it's exam scores, I don't know. We're going to say that the claim it looks like is that the mean is greater than 83.6. Let's go ahead and use test scores. Well, that's not a good one because of the data set. We'll use test scores anyway just because I can't think of anything in the moment. The claim is that the test scores are greater than 83.6. The mean is greater. Now, so the null hypothesis, as you can see here, is always equal to. Null hypothesis, always equal, always equal. I've tried to cull these out. There are some questions in my open math that don't use this. This is a new rule, I guess, for statisticians, the statistics community. It used to not be the case, but now every null hypothesis is equal to. Okay, this alternate hypothesis is greater than. The alternate hypothesis will be reverse of the claim if there is an equals in the claim. So if the claim is that the test scores would not be equal, would be different from 83.6, or if the claim is that the mean test score is greater than or equal to, less than or equal to. I'm even doing my hand motions here. You can't see me doing them, but I'm doing hand motions to emphasize null hypothesis is always equal, and alternate will be the same as the claim unless the claim involves an equal sign. So I can see my claim here. My claim is that the mean is greater than 83.6. All right, here's my tiny data set. I'm going to go to L1 and clear out my data. It doesn't have to be L1. It's just what I use for if it's convenient. I'm going to enter this data. This time I'm given a set of data. Sometimes for means it will say, hey, here's the story, here's the mean, here's the standard deviation, and then what I have are statistics I will enter into my hypothesis test. This time I have data. I'm going to L1, entering my data, and then what I am going to do is I'm going to stat, arrow over to test, arrow down to t-test. This is my antique TI-83 plus calculator. Now, in my calculator, I'm prompted. I'm going to click data because I want to do my t-test based on data and not by statistics, which have already been provided. So I'll hit enter on data. What is my null? It's given to me in the problem, 83.6. Okay. Where's my data coming from? I'm going to enter L1. If you have something different there and want to change it, you can use the second arrow key. It's above the 1, 2, or 3 if you're working in list 1, 2, or 3. Mine's in list 1. Frequency is always 1. And then my mean, I am doing a right-tailed test. See this greater than? I'm doing a right-tailed test. Again, I'm doing the hand motions, pointing to the right, a right-tailed test. So, then I'm going to arrow down to calculate, and I get a lot of stuff I don't necessarily need. What I want to know is what's the p-value and how does it compare to this given, the alpha that I'm given is 0.02. They told me the alpha. For our purposes, we'll be told the alpha. If we were on a research team, we would make some very calculated decisions about what our alpha should be, how alpha is kind of like that margin of error. How narrow are we going to be? How precise? And depending on the nature of the study, we would make a different decision. So in this case, the decision has been made for us. Alpha 0.02. What is the test statistic? I'm not using the test statistic in this case because all I want to know is what's my p-value and what is alpha, but I can find it, my test statistic, right there, my t in my calculator, 4.006. And then what is my p-value? My p-value is 0.0139. Actually, if I were going to round up, 0.014. Pay close attention to p-value because look to the end. Is this written in scientific notation? Is this number got a times 10 or a e or something at the end to the negative 14 or whatever, in which case the p-value would be practically 0. It would certainly be less than alpha. In this case, my p-value is 0.104. Alpha I was given was 0.02. So my p-value is less than alpha. It is less than alpha. So this is where, so I'm going to do my test statistic, was, what did I say? 4.0, what is it telling me here? I know this is a kind of an annoying thing to have. Oh, 3 decimal. It tells me 3 decimal. Okay. And then what is my p-value to 4 decimal places? 0.01, actually 40. Okay. By the time I round. P-value is less than or equal to alpha. I always have to go back to these notes. These notes are posted in the assignment for this week, the assignment tab for this week. So, like I said, this is not something I do every day. I must have these notes in front of me for running a hypothesis test. What do I have? In this case, I have alpha is greater than p. Okay, p is less than alpha. So here's what I'm going to do. My decision is to reject the null. I'm going to reject the null. Okay, now what the heck does that mean? Well, let's go down here and follow the flow chart. What's the kind of practical application of rejecting the null? We don't go around in our dinner conversations saying, well, I decided to fail to reject the null. What does this mean in real life here? So, did our original claim contain the condition of an equality? Let's take a look. Does our claim have an equality? We weren't given the claim, but we can tell from our alternate hypothesis that we were not given an equality. If it did contain an equality, the alternate would be a not equal to, or it would have an inclusive, like greater than or equal to, or less than or equal to. Since our null is strictly greater than, we can know that our original claim was also strictly greater than. Does the original claim, okay, not the null hypothesis, original claim contain a condition of equality? It does not. So I'm going to follow this arrow. No, it does not. Did you reject? Well, after all this talk, I already forgot what I said. We reject. Okay, yes, we see, I told you I have to have my notes. Did we reject? Yes, we did. So here's my sentence. the sample data support the claim, the original claim. Okay, so the sample data supports the claim that, and what our made-up story was, the sample data supports the claim that, I've got my answers right here. The sample data supports the claim that the population has a mean greater than, or the mean test score is greater than 83.6. And so, in my head, I would say that since I rejected the null, then I'm going to accept the alternate. Now, in real research, we're not allowed to accept. We're not out to prove anything or accept something. We're just going to reject or fail to reject. That's important. We're saying with this body of data, here's the best conclusion we can come to, and it is never, ever a definitive proof. Okay, so this is an example from my Open Math. I hope it has been helpful.